Hello friends, in this session we will see some examples on diagonal canonical form and Jordan's canonical form. Let's begin. Yes, so now let us take the first example. Let us think of a transfer function t of s is equal to s plus 3 upon s plus 1 into s plus 2, right? Yes, let us try to think of this particular example. See here. First of all, you please tell me, will there be any Jordan canonical form for this particular one? Jordan canonical form? No. Why? Because here if you see, there is no repetition of poles. There is no repetition of poles. Which means that this particular transfer function will only have diagonal canonical form. Right? So now let us try to solve that. If we know the first step which we have to do here in case of a diagonal canonical form is to find the partial fractions, right, and then just apply the matrices, right. These were the two steps. So now let us start with the first step of finding the partial fractions, right. Let us do that. See here. So s plus 3 divided by s plus 1 into s plus 2 can be written as a upon s plus 1 plus b upon s plus 2. This is the simple partial fraction method which we have already seen in our school days, right? It is a simple thing. Now let us try to find the values for a and b. These are called as partial fraction constants, right? So let us try to do so. See here. Now to find the value of a there is a shortcut, and to find the value of b also there is a shortcut. We will see what that shortcut is, because students may say that, sir, what we can do is we can just simply do some cross multiplication stuff and all, and then just solve it, right? But it is not at all necessary. Why? Because we are studying for a gate competitive exam. That is the reason you will have smaller time frame. So in a smaller time frame you will have to solve the questions with a accuracy, right? So we have to use shortcuts over here. So yes, and it is a very simple shortcut. If you want to find a, right, a, what will I do is I will write this complete equation. I will write this complete equation which is there on the LHS. I'm repeating, I will write the complete equation which is there on the LHS except the term which is there below a, except the term which is there below a. Meaning that, see here, so this a, what did I say? I will write everything. So let me write everything. S plus 3, s plus 1 into s plus 2. But I said that without the term which is present here, right here. So if you see here below a we have s plus 1, so we are not supposed to write s plus 1. That's it. That is the only thing. So now what will I do is I will simply apply the things. See, yes, so now after this the simple thing which you are supposed to do is just simply equate this pole to 0. Means just make this s plus 1 equal to 0, and then what do you get here is s is equal to minus 1, right? If you equate this denominator of a to 0, you will get s equal to minus 1. So just simply replace here s equal to minus 1. That's it. The moment you put s equal to minus 1 in this equation, you get, in place of s, you get minus 1 plus 3 upon s. Yes, so it is going to become minus 1 plus 2. That's it. This term is already not there. We have seen this term has to be cancelled out, right? So now if I just put here, so what do I get here? I get here 2 divided by 1, which is nothing but 2. So I can say that value of a is equal to 2. Is that clear? Yes. Now let us try to find the value of b. It is also going to be very simple. Let us see how it is done. You want to find the value of b, right? No. Now What did I say? Write the complete equation which is there on the left. Write the complete equation which is there on the left. So yes, let me just write the complete equation. So it becomes s plus 3 upon s plus 1 into s plus 2. But yes, except the term which is there below b. Except the term which is there below b. So here if you see, we have s plus 2. So we are not supposed to write s plus 2 over here. That's it. S plus 2 is cancelled. Now we are supposed to replace the value of s, which means just replace this as 0, just put this equal to 0. So what do you get here is s equal to minus 2, which means you are supposed to replace in this equation s equal to minus 2 in order to find the value of b. So if you just replace it here, what do you get? Yes, in place of s you are supposed to put minus 2, so you get minus 2 plus 3 divided by minus 2 plus 1. Is that all right? Yes. Which is equal to what, sir? Which is equal to, yes, it is going to be 1 upon minus 1, which is equal to minus 1. Therefore, I can say that b is equal to minus 1. Is that correct? Yes. Now, we have got the partial fraction constants, that is a and b, right? Now, we are supposed to form the diagonal canonical form, right? So, let us do that. See here. If I want to find matrix A, what will be there? Let us see. This is matrix A. Matrix A has to be a diagonal matrix because we are interested in a diagonal canonical form, right? So it is a diagonal matrix. If you see here, what will come here in place of this? What will come in the place of diagonal elements? Diagonal elements will be nothing but poles, right? Poles will be there on the diagonal elements. So if you just check out here, in this equation, if you try to find the poles, which means what, just equate the denominator to 0, which means s plus 1 equal to 0, therefore pole is minus 1. This is the first pole, and the second pole is going to be, yes, definitely s plus 2 equal to 0, therefore you get the second pole to be equal to s equal to minus 2. These are the two poles, so just simply replace them, right? So here I am going to have minus 1 and minus 2. That's it. Now, off diagonal elements will be 0. Off diagonal elements are going to be 0. They are 0. No problem. Right? Yes. Now, let us think of B. What will be there in B? B matrix is going to be all ones. We have seen that. B matrix is going to be all ones. Right? Now, let us think of C. What is C matrix? C matrix will have constants C1, C2. But now here in our case, we are having those constants as a comma b, right? Now see here, very important, this, if you see here, this a, if you observe here this a, is that above s plus 1? Yes, definitely. So here itself I will be having value of a, which is nothing but 2. Similarly, if you just see here, this b equal to minus 1, right? So this b, below b I have what, s plus 2, which means below b the pole that I have is s equal to minus 2. So the pole that is having is minus 2. So let me have this one here. Below this I will be having minus 1. This becomes matrix C. And yes, what is matrix D here? Yes, D is nothing but B naught. Now if you see here, this particular one, the degree of denominator is 2, right? Similarly, the degree of numerator is also 2, also is 1, right? Which means degree of numerator is less than degree of denominator, right? Which means it is a strictly proper transfer function. Strictly proper transfer function. The moment it is strictly proper transfer function, we know that b naught is going to be 0. So if b naught is 0, then yes, definitely this matrix D is equal to 0. This is the first question we have done. Now let us think of another question. Example 2. Yes. Now, this is the transfer function given, right? And yes, now if you see here, is there any of the poles repeated? No, there is no repetition of pole, which means that, yes, which means I will be only having diagonal canonical form for this particular function, right? So let us try to find it. Now the first step is nothing but, what is the first step? First step is to write it in the form of partial fractions. So s plus 4 upon s plus 3 into s plus 2 into s plus 6. Is it okay? Yes. Now this has to be shown in terms of partial fraction. So it is equal to a upon s plus 3 plus b upon s plus 2 plus c upon s plus 6. Is it right? Now yes, just simply use the shortcut. What is that shortcut? Let us try to find a first. A is equal to what? Write this complete equation which is there on the LHS. Complete equation which is there on the LHS. So just simply write that s plus 4, s plus 3, s plus 2, s plus 6. Is that right? Now below a, what you have? You have s plus 3. So you no need to consider s plus 3. S plus 3 will not be taken here, right? Now if you equate this s plus 3 to 0, you get s equal to minus 3, right? Which means this has to be replaced by s equal to minus 3. So s plus 4 divided by s plus 2 into s plus 6 at s equal to minus 3 is equal to what? It is going to be, yes, in place of s you need to put minus 3, so this becomes minus 3 plus 4 divided by, yes, it becomes minus 3 plus 2 into minus 3 plus 6. What does this become? This becomes, yes, minus 3 plus 4 is what? Minus 3 plus 4 is 1 divided by minus 3 plus 2 is minus 1 into, what do you get more? Minus 3 plus 6 is going to be 3. So you have here minus 1 by 3. Is it correct? Yes, definitely. Now let us try to find b. Yes. So if we are supposed to find b, then see here, b is equal to what here? Yes. In order to find b, just write the complete thing. Just write the complete thing again. So s plus 4 upon, yes, s plus 3 multiplied by s plus 2 into s plus 6, right? Is it so? No. Whatever is there below b, just simply neglect that. Just simply don't write that. So whatever is there below b, I have cancelled it. Below b I have s plus 2, so s plus 2 has been cancelled. So now just replace s is equal to minus 2. Yes, I know you may say that, sir, you are too slow. Yes, it's okay, there is no problem. Why? Because these are the basics, you need to understand them in detail right now itself. Otherwise after some time it will be very very difficult for you. So you have to understand those simple things right now. So it is okay to spend time now, it is completely fine, there is no such problem. Yes. So now if I replace s equal to minus 2 in this equation, what do I get here is, in place of s, if I put minus 2, so I get minus 2 plus 4 divided by, yes, minus 2 plus 3 into minus 2 plus 6, right? So what is that equal to? That is equal to minus 2 plus 4 is 2 divided by minus 2 plus 3 is 1 multiplied by minus 2 plus 6 is going to be 4. So I am going to have 1 by 2. This is b. This is my b. Now let us try to find c. If I think of c, what should I do then? Just write this complete equation. Just write this complete equation. What is that equation? S plus 4 divided by s plus 3 into, yes, s plus 2 into s plus 6. Is it right? Yes. Now is it so? No, I have to ignore this s plus 6, so just cancel out this s plus 6. Why? Because it is below c. Now put in this equation s equal to minus 6. Why? Because s equal to minus 6, right? S plus is equal to 0, if I think of, then it is going to become s equal to minus 6. So you please do this. So it is going to become what? Yes, in place of s you are supposed to replace minus 6, so it becomes minus 6 plus 4 divided by, yes, minus 6 plus 3 into, what do we have is minus 6 plus 2. Now what do we have here? This is going to be minus 2 divided by minus 6 plus 3 is going to be minus 3. into minus x plus 2 is going to be minus 4. So it is going to be equal to what, sir? Yes, it is going to be equal to minus 2 upon 12, which is equal to 1 by 6. Minus 2 upon 12, which is equal to minus 1 by 6. Is that all right? Yes, because this 3 into 4 is going to become plus 12, and this is going to be minus 2, so it becomes minus 1 by 6. So these are the coefficients. So this is A, this is our B, and this is our C, right? It is done now. Now let us try to find the diagonal form. It will become very easy, right? So yes, what is matrix A? Matrix A is a diagonal matrix, and it will be of order 3 by 3. Order 3 by 3. Why? Because order of the transfer function is 3. Degree of the denominator is 3, right? There are 3 poles. Now if you just equate them to 0, what do we get? You get the 3 poles as s equal to minus 3, s equal to minus 2, and s equal to minus 6. So minus 3, minus 2, minus 6. That's it. Rest I am going to have 0 0 0 0 0 0. This is matrix A. Matrix B is what? Matrix B is going to be all ones. All ones. What is matrix C? Matrix C is going to be the partial fraction coefficients. So if you see now, above minus 3, what we have? Above minus 3 means above this I have A. So what is A here? A is going to be minus 1 by 3. So let me just simply replace that. So here it becomes minus 1 by 3. After that, so this comes here. Now after that I have minus 2. So if you think of minus 2, yes, so if you think of this one, so minus 2, yes, minus 2 is here. This is B, above that I have B, so this is going to be 1 by 2, right? So partial fraction constant is going to be 1 by 2, right? After that I have this minus 6. Let me keep this here. After that I have this minus 6. So the moment I have minus 6 means above s plus 6 I have C. So C is going to be 1 by 6. C is going to be minus 1 by 6. So it is equal to minus 1 by 6. Is that correct? Yes, definitely. What is D here? Yes, D is again definitely 0. Why? Because it is a strictly proper transfer function. How do we know that? How do we know that? Because degree of the denominator is 3 and degree of the numerator is 1. So numerator degree is lesser than denominator degree, which means it is a strictly proper transfer function. And the moment it is strictly proper transfer function, B naught is equal to 0. We have already seen that, right? So this is the state space model. Now let us take one example for Jordan canonical form. Yes. Yes. So now you please tell me, are there any poles repeating here? Yes, there is this pole which is repeating 2 times. Which is that pole? This is the pole that is repeating 2 times. Right. Which means definitely I cannot have diagonal canonical form. I need to have Jordan canonical form only. Is that correct? Yes, right. So now let us try to do so. But before that, I need to find what? I need to find the partial fraction constants. So let us try to find them. Yes. So this is going to be s plus 1 upon s plus 2 the whole squared into s plus 3. It will be represented as, now see here, focus, very important. Again, you are, because since you have 3 poles, right? Here you have 2 poles and here you have 1 pole, so you have 3 poles in totality. So you need to have, again, yes, A also, B also, and C also, right? But then if you see here you have only s plus 2. So what are you supposed to write? You have to take once s plus 2 and another time you have to take s plus 2 squared. Is that correct? Yes. And then you have to take s plus 3, this pole, remaining pole, and again between them I'm going to have plus signs. This is what is the rule, right? Now you may tell me, sir, but you just told the shortcut, right? Yes, I have told you the shortcut, but that shortcut, will it be applicable here? No, it will not be applicable here. Why? Because here you have repeated poles. If you see here you have repeated poles, which is repeated 2 times, so you just cannot use that. But I can use that for this term. No, I can use that for this single term s plus 3. Yes, I can. So even if it is working in a halfway, it's okay. We will try to take the maximum advantage of the shortcut. Let us do that. Let us do. Chill. Focus. Chill. Don't worry. Things are very easy. Yes. Now, let us think of C. So, I need to find the C first. So, if I want to write C first, C is going to be what? Yes. Write this complete equation. Yes, let me write the complete equation. S plus 1 upon S plus 2 the whole squared into what? S plus 3. But now, yes, what is there below C? Below C, I have S plus 3, which means S plus 3 has to be cancelled. S plus 3, I am not going to consider. Right. Now, at S equal to minus 3, because S plus 3 equated to 0, you get S equal to minus 3, which means I have to replace here, in place of S, I have to write minus 3. So, you please do that. What do you get here? You get minus 3 plus 1 divided by minus 3 plus 2 the whole square. Is that correct? Yes. What do you get here? You get here minus 3 plus 1 is going to be minus 2 divided by minus 3 plus 2 is going to be what? It is going to be minus 1, and minus 1 squared is just going to be 1. So what do you get here? You get it as C equal to minus 2. You have got the value of C. It is correct. Right. Now, how to find A and B? So to find A and B, I have another shortcuts. Let us see what that shortcut is. Now see, listen to me carefully. See, whatever value of S you have used already, except that value, replace the S by any other value and calculate. Meaning that, let me put S equal to 0. Let me just put. Why? Because I have not put, till now I have not used S equal to 0. I have not used in the sense, see here I have taken S equal to minus 3, right? Now let us take S equal to 0. But now, in order to replace S equal to 0, I will be replacing it in this whole equation. Now, in this whole equation, you have unknown as A is unknown and B is unknown. But you may say that C is also unknown. No, you have got the value of C right now, so C is known. Similarly, everywhere you have S here, you have S here, all the values of S also you know. Why? Because you are assuming it to be 0. That is the shortcut. Let us try to apply that. Means in this complete equation, I will replace S by 0 and C by minus 2. Let us do that. So put S equal to 0 and C equal to minus 2. If I do this, what do I get now? Yes, definitely. Let me just take down the equation first. So now let us replace S equal to 0 and put C equal to minus 2. So in place of S, let me write 0. So I have 0 plus 1 divided by 0 plus 2 the whole squared into 0 plus 3, right? Which is equal to what? Yes, A will be there as it is, divided by S plus 2. So let me have 0 plus 2 plus, again, yes, B will be as it is because it is unknown, divided by 0 plus 2 the whole squared, plus what do I have is, yes, C equal to minus 2. So let me replace it by minus 2 upon 0 plus 3. Is it correct? So now this thing becomes 1 by, this 2 square becomes 4. 4 into 3 becomes 12. So it is going to be 1 by 12, which is equal to A by 2 plus B by, again, 2 squared is going to be 4. So I have B by 4 minus 2 by 3. Right. So if I take this one side, what do I get is, therefore what I get here is a by 2 plus b by 4, right? It is equal to, let me just take this term that side, so it is going to become 1 by 12 plus 2 by 3. The moment it is there, what do I get here? I get 2a. Now what will I do? I will just multiply and divide by 2, such that I have at the end, I will have here 4 on the down, so it becomes 2a plus b upon 4 is equal to, now here what will I do? I will just multiply and divide by 4. What do I get then? Yes, I will get here 12, and on the top of it I get 1 plus 8. 4 plus 2 is 8, right? So now let me just put this 4 here. What do I get then? I get that 2a plus b is equal to 4 multiplied by, yes, 1 plus 8, which is 9 divided by 12, right? So 4 ones are 4 threes are. What we have got? 3 ones are 3 threes are. What have I got here is, yes, I have got 2a plus b is equal to 3. Let me call this as equation 1. Let me call this as equation 1. This is done. Now see here, we have two unknowns, right? Yes, we have unknown a and we have unknown b, which means you need two equations to solve them. Yes, right? So the moment you need two equations to solve them, out of those two equations, one equation you have already got. Now you want another equation. For that, we will do the same procedure. What is that procedure? See, yes, if you just see here, initially if you see, I just replaced s equal to minus 3, which was right. Why? Because after putting s equal to minus 3, I got value of c as minus 2. Then what did I say to you? I said that you can put value of s as any damn value except the value which is already used. So already s equal to minus 3 was used, so we just cannot use that again. So I just told you that, yes, you please do s equal to 0, because calculations will become simpler. Even if you do s equal to 100, the same equations you will get. You can try that out at home. Anyways, now let me just put s equal to 1, because it seems easy. You can put any damn number, it is fine, there is no problem. There is no such this thing, hard and fast thing, that s should be equal to 0 only, minus 1, 1, 2. No, 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 no problem. I am taking 1 for simplicity, that's it. Now let me just put s equal to 1 and c equal to minus 2, because c equal to minus 2 we have already known. So let me just put s equal to 1 and c equal to minus 2 in which equation? I will be writing that down. So in the same equation, right? Yes. Now if I put in place of s, I will put 1, and in place of c, I am going to put it as minus 2. So what do I get here? I get 1 plus 1 divided by, in place of s, 1 plus 2 the whole squared into 1 plus 3, which is equal to, again, yes, a will be there, and 1 plus 2, plus again, yes, b will be the same, and again 1 plus 2 the whole squared, plus again, yes, c, in place of c I am supposed to replace minus 2, so it is going to be upon s is going to be 1 plus 3. Is that right? So here what do you get here is, yes, 1 plus 1 is 2 divided by 1 plus 2 is 3, 3 squared is 9, and 9 into 4 is going to be 36. So it becomes 36, which is equal to, again, yes, a by 1 plus 2 is 3, plus, yes, b by 2 plus 1 is 3, 3 squared is 9, so it becomes b by 9 minus 2 by 4, because 3 plus 1 is 4. Right? Now what do I do here? Let me just do the simple things, in the sense, yes, let me just take this one that side, let me just take this one that side. So if I do that, what do I get here? By the way, this 2 by 36 can be resolved as 1 by 18 or not? Yes. So I will be having 1 by 18, which is equal to, yes, a upon 3 plus b upon 9. Is that all right? Yes. Now what do we have here? Yes, this is 1 by 18 and this is, wait, yes, this minus 2 has not been taken. Let me just take that. Yes, this term was taken that side, no? So it becomes plus 2 by 4, which is equal to a by 3 plus b by 9, right? So now the moment you do that, what happens here is, yes, what happens here is, you get, after solving this, you get 1 by 18 plus 1 by 2, right? 1 by 18 plus 1 by 2, which is equal to, let me just I'm having this a by 3, right? So let me just multiply and divide it by 3 plus b by 9. So what happens here? Yes, it becomes 1 by 8 plus 1 by 2, 1 by 18 plus, right, 1 by 2, if you just think of. So what happens here is, what happens here, because this is going to be 3a plus 3b, so this becomes 9. So I am going to have here 3a plus 3a plus b divided by 9, which is equal to 1 by 18 plus 1 by 2. So 1 by 18 plus, in this 1 by 2, in this 1 by 2, let me just make it 9 by 18. Is that possible? Yes, just multiply and divide by 9. That's it. So it becomes this way. So I get 10 by 18 into 9 is equal to 3a plus b, right? 9 ones are 9 twos are 2 ones are 2 fives are. Therefore, what do you get here is 3a plus b is equal to 5. This becomes equation 2. Let me call it equation 2. Now if you observe here, this is equation 2. In this you are going to have 3a plus b equal to 0, whereas in equation 1 you have got 2a plus b equal to 3. Now if I want to use the elimination method, which means let me just subtract 1 and 2, what do I get then? Yes, this b and b will get cancelled and you will be having a value, right? So let me just subtract them. So equation 1 minus equation 2, if I do, what do I get here then? Yes, I get 2a plus b is equal to 3 and minus, yes, definitely I get 3a plus b equal to 5. What will I do here? I will change the sign. So this becomes minus, this plus becomes minus, and this becomes minus, right? Yes. So now what do I get here? Yes, 2a minus 3a, you get minus a, plus b minus b gets cancelled, and then here you have minus 2. 3 minus 5 is going to be minus 2. So if you think here, therefore a is equal to 2, right? Similarly, now what will I do is, I'll just put a equal to 2 in equation 2. What do I get then? Equation 2, I am having 3a plus b equal to 5. So 3a plus b equal to 5 is the equation. Therefore, if I put a equal to 3, I get 3 into 2 plus b equal to 5. Therefore, yes, b is going to be minus 1. So now you have got a and b as well. Now let us try to find the matrix. Diagonal canonical form. Let us try to find that. So if you think of A matrix, in A matrix is a diagonal matrix, we know. Yes, definitely A matrix is a diagonal matrix, right? And it is going to be 3 cross 3 matrix. Why? Because you are having 3 poles. Then yes, if you just remember that, yes, here if you see that one pole is repeating 2 times, so let me just make a partition for that. So I will simply make a partition for that pole as usual, right? Because it needs some safety, right? Yes. So yes, now what is that pole which is repeating? What is that pole which is repeating? S plus 2 the whole square, right? Which means s equal to minus 2 is repeating 2 times, right? So let me write that minus 2 and minus 2 here. Is that okay? Yes. And what is the remaining pole? Remaining pole is s plus 3, which is nothing but s equal to minus 3. That is the remaining pole. So let me have the remaining pole here. Is that okay? Now yes, definitely it is a diagonal matrix, so it is going to be 0 0 0 and it is going to be 0 0. And we know that since this minus 2 has been taken 2 times, there has to be some change. So as a change, what we have is here we have 1. We have already seen. Because if this one is extra, then yes, definitely there has to be something else written here, which is 1. Otherwise, it will become our simple diagonal canonical form. By the way, is it a diagonal canonical form? No. It has to be a Jordan canonical form. Why? Because poles are repeated. Which pole is repeated? S equal to minus 2 has been repeated twice. Now, let us think of B matrix. If we think of B matrix, in B matrix what we have is all are ones, right? But if you see here, this one has been already taken here as a compensation. So here I will not be having 1, rather here I will be having 0. So B matrix is going to be 0 1 1. Now what about C and D, sir? C matrix is going to be the same. A, B, and this. Where is that C? Yes. So, yes. Where is that C? Yes, it is here minus 2. So, I am going to have 2 minus 1 minus 2. So, these are partial fraction constants, 2 minus 1 and minus 2. Right? Yes. Now, what about D matrix? D matrix has as usual B naught, and that B naught is going to be 0 because it is strictly proper transfer function. How do you know that? Because you saw here that yes, degree of the denominator is 3, whereas degree of the numerator is 1. So numerator degree less than denominator degree, which means it is a strictly proper transfer function, and strictly proper transfer function B naught is equal to 0. So in this way we have solved all the examples related to diagonal canonical form as well as Jordan canonical form. Thank you.